This blue ball is made up of silicone gel. The blue color comes from cobalt. Yet, this crazy ball defies gravity. It kind of crawls down the wall and does not want to come down. For those of you who are aware of, these are van der Waals forces. Here you can see it weighs approximately 99 grams. That's almost 100 grams. So it's not a very light ball. The reason why you can see it's bouncing on a proper table or the floor is that the floor is smooth. There are no cracks or crevices in the tiles surface. Now let's just take him and we're going to throw him up onto the ceiling. Let's see what happens. He's up there. Yeah, that is the ceiling. And silicone gel is made up of hydrocarbons. What are silicones? They're polymers that contain chains and chains of hydrocarbons, and they have hydrogen and oxygen. The ball is a branched chain silicon polymer. It has properties that fall between a solid and a liquid, commonly described as marshmallows. This ball possesses a sticky nature that comes from its molecular structure. Long chains of polymers entangle and provide the tacky consistency. When pressure is applied, these chains find their way into the minutest crevices, ensuring a strong bond. So they are millions of tiny loose ends on the structure of the ball, which attach to which find all these minute crevices and go. This is something to how a lizard can climb a wall. Lizards have a very large number of tiny hairs on the pads of their feet called setae. These hairs have again tiny pads at their tips known as spatulae, which are about 1/10 of human hair in diameter. These tiny pads therefore drastically increase the surface area and come in intimate contact with the surface on which the lizard is crawling. So the van der Waals forces kick in. Although normally considered negligible, in this case the van der Waals forces combine to form a pretty strong force. Teachers in schools can use this example using this silicone gel ball to explain van der Waals forces to the kids. I know it's not easy getting a lizard into the classroom and explaining, but yeah, this ball has such a fun use and a good way to explain this force. Atoms have electrons, which are negatively charged particles. These revolve around the center of the atom or the nucleus. Molecules are formed by the donating and accepting or sharing of electrons. As mentioned, these electrons are not fixed in one place. Instead, they keep moving. Therefore, this leads to times where a large number of electrons collect at one end of a neutral molecule, creating a negative charge on that side and also attracting a positive charge of another similar electron towards it. These forces are known as van der Waals forces. Since the strength of these forces is quite small, they only come into play when two molecules come pretty close. For these forces to have considerable effect between two different surfaces, the two must have to come very close to each other. That is why you have to squeeze the ball onto the surface of the wall, or when you throw it, all that kinetic energy presses the ball's surface right down to the wall's surface, and the molecules come close enough that they are good enough to feel van der Waals forces. Seriously guys, pixie dust? Come on, nobody's going to believe me.